turn it on.
Yeah, ladies and gentlemen, just want to grab a drink and grab a seat or a comfy spot, somewhere to lean against, and we'll get into this in a minute or something. If that all makes sense. You two, you're like out of the Muppets. You need to go and sit in the back somewhere.
That's why we're here.
Yeah.
So we can hear you.
Yeah.
No mumbling, no talking.
Hear me and see me. Okay, ladies and gentlemen, thank you very much for joining us this afternoon. I know we're cutting into what's normally a very social first evening of the METS trade show, so welcome to all of those of you that I haven't managed to catch up with yet, and thank you for coming along to just give us the opportunity to have a little chat about our journey to date in the world of cableless and structured luff sales. And I very much say that journey to date because, you know, we really are only scratching the surface, and many or most of you, in fact, here obviously out of the industry in some shape or form, and, you know, this is something which, you know, we obviously believe in and have been doing a lot of work on, and so today we just thought we'd take the opportunity to just try and bring everyone up to where we're at. So with me today, Matt Bridge, most of you know, or if you don't know, we might have a beer with later on. Matt's very much considered one of the experts in the world of super yacht sale coordination, and great to get his perspective on what this technology offers from a super yacht standpoint. Richard Bazade, who's our principal designer for the Doyle Sales Group, one of Duffy and my partners, one of the founding members of Doyle Sales New Zealand, and you know, a long-time association with Robbie Doyle, who's here somewhere. Richard's, you know, one of the few sailors which has won the America's Cup and the Volvo Ocean Race as a sailor, and has been designing sails for many years, and a long family history of sail making. So it's nice to have the Bazades. If anyone wants to ask Chris, he wants to sit up the front so that he can answer questions as well. So. And then Stu Bannatyne, the only man to have won the Volvo Ocean Race 5 times. So, you know, unquestionably 4. He just won another one. 4 times. So I've been telling lots of people it's 5. You will have to go again. So, yeah, you know, vast amount of experience. Won most ocean races and inshore keelboat races and dinghy races that we have around the world. So that's our little panel up here today. I'm here to quiz them with some good questions. This is very much an open, you know, an open forum. We'd love, you know, if anyone's got anything, we'll have a question session at the end, but if, you know, if we're speaking about something and you want the guys to dive deeper into that topic, you know, feel free to jump in and, you know, ask any questions, and we'll get into it. So we're going to start off with a little video, just showing the journey to date.
It's been 3 years now since sort of the first cableless sails started appearing on boats, and since then the evolution, even a revolution really, of the design of these sails has been amazing for the industry.
The theory is load sharing, and we learned in early tests of this technology that we could spread load through the membrane more effectively and efficiently to reduce the loads, or make the loads work for us rather than be fighting loads. And as the technology has evolved, we've learned that it's applicable to just about every sail.
They started off with the Code Zeros, sort of semi-flying spinnakers, and as the technology's developed and the designs have evolved, then we've been able to push it even further into tighter angle sails. So the benefits of the cableless technology are many, and you know, we hear different sort of feedback from different crews just absolutely raving about how easy the sails are to handle, how much lighter they are, how much easier they are to fold into bags and into sail lockers without cables, and that goes right from sort of 50-footers right up to super yachts.
One of the bigger challenges that we've got with super yachts, particularly as the designs get more and more performance orientated, is the huge loads that they're creating. And that's only getting worse, but the potential to make these weight savings and performance gains and keep everything a little bit safer and a little bit lower loaded is really exciting.
With the new technology that's going on now with these cableless and structured luff sails, the gains that can be made in the mast design, rigging, even the hull structures is incredible.
For example, you can take this technology and reduce the weight of the mast, the stays, the potential boat structure. The loads could be reduced by as much as 50%.
Because of the technology, we're able to make the mid-girth Code Zeros flatter, which means that they can be used at much tighter angles, and the ability to change the shape of the sail by just easing the tack up or changing the lead a little bit means that we're getting a lot more range out of the sails as well. So as well as filling a big gap, they're proving to be a lot faster as well. So the trimmers are happy, the owners are obviously happy. The durability of the sails has been amazing as well. With the Stratus technology, the way we're building them, the sails are lasting as long as the owners want to use them for. And the way the development's been going, that's quite often not more than a year or 18 months before we can make a pretty big jump in design, just because we're developing these sails every day. Every new sail that goes out is, a small tweak better than the last one.
Good sails make boats go fast. It's pretty basic, really.
Nice. So that just a little recap on some of the projects which it's been involved with, and some thoughts from the guys. So we're going to kick off here. I've got a bunch of questions to put to the panel. And we'll start with Richard. We heard a bit about where the technology began and the evolution it has been through in the video, but can we dive into a bit of the detail of the theory behind the cableless and structured luff technology?
Yeah. Hello. All right. Yeah, absolutely. The first cableless sail that we made, or probably the first cableless sail, was it's up on the board there, was a development sail for Bellamente, where we, many of you guys who are involved in racing, some of the rules around sail restrictions and Jenicas require mid-girth that's 75%, and one of the problems is these boats get faster and faster. That style of sail just isn't very suitable, and so the game is to try and make that sail flatter and flatter. So what we did is we looked at the sail and determined that we try and build effectively through structure the cable into the body of the sail, and have the, if you like, the sail almost reef itself. Interestingly, when we did that, we discovered a few things that were unexpected, I guess. One was that it furled very well. The cable-less sail furled as well, if not better, than a conventional bottom-up cable sail furled. Secondly, we found that the way that the load was being spread into the membrane, because of the structure that had been put into it, the sail flew completely differently. And from basically there, that type of sail, as you can see on the left, it got banned pretty quickly by the rule makers, as you can imagine. But it pretty quickly evolved into, the picture on the right, if you like, and that's where the current, if you like, Code Zero sail is, cableless sail that has the structure built into it to basically take the load into the membrane and away from the leading edge.
Yeah, nice. So, we've had some massive benefits, obviously, too, in staysail world, with the ability to almost choose how much tension you want on the luff, allowing, it to become a strong reaching mast tune, almost a negative check. Stu, maybe talk us through exactly, how the sails are able to fly with more luff projection, for less luff tension, and Richard, this is something that you and Stu could bounce backwards and forwards with here.
Yeah, one of the great advantages of the cableless sails is that they can be used now on these, I'll sort of talk more towards the racing side, but a lot of the boats are engineered for a given load to basically not put too much weight into the boats. And that was always a compromise, you know, when you had your old cabled Code Zero on the tack of your Maxi 72, you could only go to 6 tonne, which was never enough. And now, with the cableless sails, you know, you're seeing a lot less than that, to the point where new boats now are being engineered with lower loads because that's all you need.
Yeah. Nice, Richard. Just want to follow up on that with the actual sort of exactly how it works, and you know, from a sail design standpoint, how is that achievable?
Effectively, what we're doing is, as sort of Stuart alluded to, we've been sort of in a cycle of, I guess, ever increasing loads, and you know, you're getting to this point that you're having to engineer, as you say, the top of the rigs and bowsprits and stuff for these, what were becoming ridiculously high loads. What we've been able to do, if you take the 72 is a good example to look at, because you know, we used to use on those boats a cabled Code Zero sail, with a load of about 6 tonnes up the front of the off the prod, maybe a 7 tonne head load. Yeah, the new sails, or the cableless sails now, we're at about 3.5 tonnes is the maximum load we're seeing on the tack, and which is under 5 tonnes at the top of the rig. Obviously, yeah, if you took that into re-engineering a prod or the rig, it's a pretty big weight saver.
Yeah, Matt, we've had success applying this technology to a wide range of boats, but specifically for super yacht. Let me ask, under a few headings, without getting too long in the answers, what cableless has to offer a super yacht? Where do the gains in performance come from for a super yacht in your experience?
Well, one of the big things is the range of the sails. A lot of boats now are using code sails as their primary off-wind sail for cruising. They're not flying Jenicas, traditional nylon sails. So their code sail is their primary off-wind sail that they're using all the time. And the cableless, because you're able to have that luff flying close to the centre line, you can set at much higher angles. So you might be getting them on at 70 degrees true and 6-7 knots of wind. Yet at the same time, at the other end of the range, you're using them in what was traditionally A3 territory. You can be at 20, 25 knots down at 140, 145. So the sails, the ability to project the luff, get it on centre line, and then ease the tack up, get it flying forward at the deeper angles, it's a tremendously versatile sail. And that's a real game.
Yeah, and obviously there's some significant handling gains, and with getting rid of some big grunty cables out of the front, you're seeing that have a big effect? Oh
yeah, for sure. I mean, some of these cables were getting pretty outsized on the bigger the boat. They were just getting the cables alone. Then you can put the sail on the outside of it. You'd be lucky to get a radius of 2 meters on some of the coils on these big boats. That's gone away now. You can get it into a deck locker easily. It's less people to handle. If you're cruising with an owner, you can get it up with 3 or 4 people, or hoist it straight out the locker. It's all a lot more manageable. Same with the staysails as well.
Yeah, I mean, and this was a pretty cool scenario here. This is G2, the ex-Cinderella, and the Code Zero literally didn't fit in the sail locker. Jason, the captain, asked, what could we do to test to see if a cableless one would work? So we whipped the cable out of this one, or he did, and they rolled it up, flaked it in the sail locker, checked that it would fit, and then we built a cableless one, and sure enough, this fits in. My next question to Matt was to ask about, the furling reliability of a sail like this. But just to go back one slide, Emma, one thing which has been cool is, as you can see, this sail doesn't have UV on the leech and foot, and they're so comfortable about the reliability of it. The sail's actually in the loft and palm are having UV put on the leech and foot. So from a cruising reliability, Matt, we're seeing this probably more and more, right?
Yeah, that's right. People are just leaving them up longer and longer because they can rely on the fill. It's not going to come undone. And there are
several things that factor into furling reliability. All the sails will fill easily enough. It's what they look like when they're filled up and you've got to get them out of the sky. So we got the slide with the furling diagram?
Yeah, that's sort of a good example. On the left, your Maxi 72, and as Matt's alluding to the next slide we'll get to, but you've basically got your worst case scenario there, which is a full sail, short foot, 75% mid-girth, and then you've got a very reliable furl, which is a flatter sail, not driven by a rule, a higher cloud, so you've got a more consistent sheet load into the furl, as I said, and the depth, which isn't there because it doesn't need to meet a rule. If we flick to the next slide, Matt, just talk us through. Oh, yeah.
Okay, so this is talking about the three factors that make a reliable furl in these sails. The picture on the left is the sort of the worst case scenario where you've got a low clew, and that furling line is the line that the clew travels on as it furls. The angle of the top of the mast to the end of the bowsprit is quite relative to that as well, and the overall depth. So if you can then make a sail like the one on the right, which is you can see the furling angle is a lot more of a steady, even ease. And you've got that shallower angle between the masthead and the end of the sprit and the high clew. And when they're like that, they just furl away and they stay away really easily. Now, obviously, not all sails can be built like that, but we do have solutions we'll talk about in a minute for what we do with when we're forced into making a sail like the one on the left.
Yeah, and what we've learned over time is you can have a full sail, but it can't, if you want reliability, you can have a low cloud, but if you want low cloud and a reliable furl, then you can't be full and high aspect. So you can have some option and still have great reliability. If you have all the worst case scenarios, then you need to look at other options of furling it. One thing to remember, and Richard reminded me of this today, is bottom up furling a 75% mid-girth sail has always been tricky, and cableless doesn't stop that. But what it does do is gives you so many options. And I guess the big thing to remember there is that we're talking about, predominantly how the sails fly as opposed to getting them, when we talk about cableless, we're talking about sails which go faster and are easier handled in a straight line. And we can, there's plenty of options with regards to how to handle them. But Stu, in a similar way to Matt, let's talk about the benefits of, having this technology on a race yacht. Why are you seeing gains in performance adding sails to existing boats? Give us some examples of successful retrofits which have seen performance increases. Comanche's J1 is, obviously one of the more high-profile candidates which we've done, and so just talk us through that a little bit and what you're seeing.
Yeah, so it comes back to what I sort of mentioned before about the boats being engineered for less than ideal loads at the times, but it's almost now that that engineering is okay now for the sails that we're developing. I can use a couple of examples. I've done quite a bit of sailing on Wild Joe this year, and we've developed a nice cableless masthead zero for that. We were told the bowsprit had a max working load of only 2.7 tonne, which seemed not enough, but we've never had a problem with it. The masthead zero we've developed for that boat goes to 65 true wind angle and sort of 7 or 8 knots of wind, and it's also our VMG downwind sail in 25 knots. So you can see the range you're getting from it. Another sail on the Wild Joe as well, a cableless Genoa staysail. It's one of the earlier ones. It's been on the boat for over a year now. It very quickly became the crew's favourite upwind sail in sort of 18 knots, 20 knots plus. It was never designed to be a heavy weather jib, but they started using it as one. And the boat doesn't have a check stay, yet the luff was staying straight enough and the mast wasn't overbending. So that was almost a by accident discovery. One day the crew found that was giving them some really fast numbers.
Yeah, and just to speak further on the Comanche, so Comanche was converted from having the J1, which is this size jib, hanked on the primary forestay. They decided to go to a lock and a furling J1, and so they put a 30-ton lock in the rig because that's what they had been requiring on a conventional jib. And, you know, they were getting significant headstay sag, which, you know, was acceptable. It was one of the choices they made with the boat. That's quite a low runner tension if you consider that we have, you know, 16 tonnes on a Maxi 72. When we put the new cableless J1 on, we went, the guys were, to be fair, were only probably sailing with 25, 26 tonnes. They were never using the whole 30. But we now go upwind on Comanche with 17 tonnes on the headstay, you know, on the head of the jib, and significantly less forestay sag. And so, you know, when we talk about percentage decreases, we've got a real live case here. And what we've got to always be careful with is the trimmers will always take the luff straighter. So when when you talk to us about what's the possibility from a luff load reduction, we've got to keep some variable the same. If you want to keep the sag the same, then obviously you can see a massive percentage gain. Invariably, though, your trimmers will ask you to get the headstay up on centre line, and so we see that obviously eat into the gain a little bit. But yeah, this is, you know, Comanche goes upwind in, you know, 20 knots max with a full cableless jib up, which is held to the forestay by a carabiner clip at the top, and that's all, you know, so it's totally free flying.
Is that the forestay you can see in the picture?
Yeah, that's the forestay. Yeah, that's the forestay, yeah. Stu, there was always a lot of discussion on the reliability of the furl, and we touched on it before. Can you talk about what the options are? Obviously, we saw in the Maxi Worlds this year, probably in the Maxi 72s, where the racing had got very tight and the whole fleet had cableless sails. You know, 2 years ago it was a lot easier. We were the only one on Bellamente with one, and we'd go 50 seconds quicker down the reach, and so we'd be happy to burn up a bit of that with the handling. You know, now with the whole fleet having them basically, you know, it was hard to get the tacticians to put the bow down to get it out of the sky. What are the options? Obviously, you know, the crews have still got to be able to race the boat. Tell us a bit about what the development's going on there.
Right, so the handling options are basically with your cableless sail is to leave it as a bottom-up sail, and you know, it really comes down to a discussion with the team and what their racing schedule is going to be. You know, we did a new A2 for InfoTrack last year for Sydney Hobart, which was actually a 77% mid-girth sail, and we had a good technique for furling that, where we gave ourselves room to dial down, and we always did a reliable furl. But if you're going to race that round the harbour, then you can't do that. So we've, in conjunction with our guys at Doyle Rigging, we've basically developed a very small, lightweight cable that we're going to use for top-down furling now. So we've used it on a few occasions already with some of these 75% mid-girth sails in various regattas, and everyone's just super happy with the reliability and confidence of the furl. You know, instead of having to do that bear away, you can carry the sail right to the mark, furl it and drop it afterwards, and, you know, hoist it again before you go around the top mark. So it's really a decision based on the type of racing you're going to be doing and how much you want to give away or not give away on the manoeuvres, really.
Yeah, I guess the key point there, Richard, is even if, you know, we're talking about solving a handling solution, but that doesn't detract at all from the concept of the sail, you know, just, you know.
Yeah, exactly. I mean, when you're dealing with a big, thick torsion stay, they do tend to, you know, dictate a bit the way that the front end sets up. But these new sling stays that the boys are making are really have very little effect on the way that the luff sets up, the way it flies, so that they're flying pretty much just like one of the sails without anything up the front edge. So yeah.
So in terms of cableless and structured luff sails, in many applications we've introduced what we call the luff sling and the leading edge of the sails. Guys, let's talk on how these work and what are the benefits of having them in some instances. Richard, talk us through how the interaction works between the luff sling and the sail and the effect it has on the depth of a jib in particular.
One of the things that we've found is, a bit like if we take a rope up at the edge of a sail to one end of the spectrum, Jenica, you have a rope up the luff of a Jenica to stabilise that edge as the sail stretches, and so we use them for the same tool, if you like, in these sails. What we find is if you take a Code 0 sail or one of those sails that we saw on like a super yacht, it can be a very small cable because it's taking very, very little load. Typically, in that type of sail, we use about 10% of the overall load would be seen on a cable or luff rope. As you move through the spectrum of sails all the way through to a jib, which we've got up on the screen there now, this is just a regular. Now it's using the head stay because the boat has a head stay and the rule requires that it be a head stay. So it's using the head stay effectively as its luff sling. And in this case, in these type of sails, you might be anywhere between 30% of the load on the cable up to, depending on the limitations of your halyard lock or your furler or whatever you might be attached to, it might be 80% on that sling, but that ratio is very important to the way the sail sets up and also to the design of the sail.
And why still the requirement for what we call the lens down the front?
The whole show, the way that the cableless sail flies, if you can imagine, you take a sail that would normally fly off the stay and hang off a stay, and now we're making a sail that really is disregarding the stay, and it's flying in its shape just through the way that the membrane is loading. So, to achieve that, it's done through one is the structure and our method of manufacturing sailcloth and sails. It's quite conducive to the flexibility that we get in structure. And so one of the big evolutions has been the evolution of the structure. The shaping of the sail is very, very important because, again, as the membrane loads up and the structure loads up, it affects the shape. And so we use these luff panels, lens panels we call them. You may be able to see them in the picture. I can't really see the picture. But these are full length, effectively radial panels which put the shape into the front edge of the sail in a certain way and react a certain way when the sail loads up.
Nice. And Matt, by having a sling in the front, obviously, that does a nice job in defining the leading edge. So from a furl standpoint, we're seeing an increase in reliability again.
Yeah.
Not that it's an issue in a jib type sail, but that'd be fair, right?
Yeah, absolutely. It's just making the whole thing set up that much easier and less just giving the sail something to furl around as well. And particularly in the staysails, which I think is a real easy conversion for a lot of these big boats. They've already got locks. Most of them are using removable staysails so that when they go racing they can tack. But the staysails go on for cruising. They've got rams and the furlers already, so it's perfectly set up to go straight into one of these structured luff staysails. Then by putting the luff sling in there, you can still use it to stabilise the rig when you're motoring. You can have the sail, leave it up, leave it furled up, and you've got the extra security that it does have a sling in the front that you can rely on that's going to stop the mast pumping when you're motoring, or if you're just using it as a stabilising sail. So for as an opportunity to get into these big super yachts with structured luff jibs, they might not be fully ready to commit to a full headsail, but a staysail's a no-brainer.
Just sort of further on that, it's quite hard, I think, often too for for the people on the boats or the boat captains or whatever to sort of to get your head around the fact that there isn't a stay holding your mast up, that it's just the sail and what happens if the sail breaks. And so hence, typically on a Komachi type sail or something like that, the luff rope or sling that's up there is always strong enough, if you like, that the brake load of that would hold the rig up should your sail fail. The reality is, sail failure is highly unlikely because the amount of fibre that's up the leading edge is a lot more than what's in a stay. And that's part of the reason that the cable sails work so well, is that they stretch less than a stay.
So from a performance point of view, one of the main advantages here is obviously the reduction in luff sag and the positive luff projection that the sail creates. How does that, we touched on a bit before about the importance of the lens, but, Richard, why are we seeing, a performance increase from, is it all from the projection out the front? Is it all from, the increase in driving force from that bubble in the front? What's it all about?
I think it's a combination of lots of things, and the performance gain is sort of, it's significant on some boats. That a good example, actually, if you look at the multi-hull shots there, and there's two different styles of downwind sail, a cabled one on the left, so these are the two right-hand pictures, sorry, and then there's a cableless one on the right. And it's pretty clear and visual to see what the differential is. If you looked at that in sailcloth on the leading edge of that sail, it's probably a metre in the middle of that luff of additional sailcloth on the leading edge of that sail. And taken in these cases, in that particular sail, we were matching a certain area, so that effectively came off the back of the sail. The leading edge of the sail is generating a lot more drive force than the back edge of that sail. I mean, pretty much all the work's going on at the leading edge of a sail as it is on the leading edge of most force. So, it's a fairly easy conclusion to come to, that you prefer to have that there and not have it.
Yeah, and it's, again, not to keep quoting Comanche, but it's one we've obviously done a lot of work on with the J2, which is the sail, one set of spreaders down, one tack fitting back from the bow, on the assumption that the leech has to stay in the same place because it's going to crash against the spreaders. Just purely from the projection and luff, the sail area of the J2 from a conventional one to a cableless one goes up 30 square metres. And if you consider where that 30 square metres is going, then suddenly it makes a lot more sense why the drive, where you're getting the increase in drive force from. And these two pictures of the Orma and the Mod 70, they were actually taken on the same leg on the same day, going down the same run, of the same race, and so it was a nice clear display. And on the left, the 18-foot skiff, that's the same boat and the same day. They just went and quickly swapped jibs. So, they're both good versions of cabled sails that they were competing against. The reduction in loads that we're seeing when these sails are being designed and fitted is revolutionary, and can be up to as much as 50% less than a conventional code sail or jib. Let's talk about how this will impact how yachts are being designed and built. Richard, working with some of the world's leading rig designers, can you disclose some of the reduction in compression loads you've been seeing?
Yeah, absolutely. I mean, we've done a lot of studies, and the tools that we have for designing these sails have been, it's sort of staggering. Every time we put a new one out there that we've designed and we've done a lot of modelling on, it's absolutely incredible, well, to me anyway, how accurately the tools predict exactly what's going to happen and how that sail is going to set up. And I think that's part of the reason we've managed to evolve it so quickly and without going broke and having to replace sails because they aren't any good, is that the tool works so well. I mean, so we've done a lot of cases now in looking at the effects of when you're building a new boat, or what those effects could be and how you'd use them. So sort of up on the screen there is a bit of an example just of an output of what the difference is between a conventional sail and where you could go with a cabled sail. Obviously you've got the cabled sail, which has a fair amount of headstay sag, and that is something it is a big problem on these bigger boats. You just can't generate in a conventional sense enough load on the headstay without everything just getting so ridiculously large, and the span is obviously so long. And then as you move across to the, I think to the right, I can't see it probably, but it's the structured luff sail again. In these applications where you're potentially starting from scratch, and you're not working under the limitations of existing hardware on a boat, you've sort of got an open sheet of paper. And in those sort of cases, I'm not sure what the number is on the board up there now, but it's probably, we've reduced the headstay sag in that application from 1.5% or something like that, which is a typical super yacht sag, for example, down to probably somewhere in the 0.5% range, which is what you're lucky to get to on a Maxi 72, for example, that uses incredibly high tensions. So what that means overall, depending on the configurations, but it can mean anything from a smaller head stay, a smaller back stay, obviously less carbon fibre out of the mast, potentially carbon fibre or structure out of the boat if those loads are driving the structure, or as we talked about earlier, you just take it all and just have much higher safety margins. It can sort of be used in lots of different ways, and depending on the way that how aggressive you can push it. Without a doubt, as Mike referred to before, you can look at potentially dropping those loads by over 50%. Your head stay loads and back stay loads by over 50%, and have a straighter stay than you currently have now. So it's pretty large where you can push it to if you start to push to extremes.
Yeah, we obviously touched already on on what that could mean, from a boat design standpoint. But Matt, from structured luffs, I can hear the super yacht people now saying, yeah, but I've got to be able to motor up wind and waves. I've got to, just tell us a bit about how comfortable we would be, for example, using the staysail example of locking the rig in and doing everything that the guys want from it as a steadying sail, as a motoring sail,
I've got complete confidence that it'll be able to handle those loads. The sail loads it's going to see are always going to be bigger than in those scenarios. When you're motoring, pounding to a head sea, still not as much as when you're
just over 25 degrees.
Exactly. So it's not really an issue there, and I think we've seen some pictures of Comanche that doesn't really have a traditional forestay, and that might be a fairly intimidating prospect for some people. And the nice thing about this technology, it can be used with on a much more conservative setup. You can still do it with a normal head sail furler, and you get perhaps not the full advantage, but you can take some of the load into the sail and start getting that back up on centerline, reducing the sag. Loads coming down, so you don't have to go the full hog, I guess is my point.
And just caught Christian from Marisha 3 out of the corner of my eye. And one of the first boats which we started sort of getting our head around this is when we did the big refit on Marisha a couple of years ago. They didn't want to, Jeff didn't want to change the furler unit to having a Cunningham, a real-time setup on it. Any sort of tack control, and so what we did is we basically Richard engineered the sail to just be slightly stiffer than the forestay, so that as we went up through the wind range, basically the luff of the jib automatically got tighter, and that was one of our early indications of, hey, there's something going on here that we can start making the jibs do more and more work. And that worked beautifully. You literally pull the tack hand tight when the topmast's all the way off, and in 20 knots of breeze, the jib luff's beautiful and tight because the forestay's stretched significantly and the jib hasn't. And that was probably the start of some of the early ones. Stu, just tell us a bit about, obviously race, going into race boats in the world of foiling and weight, and we're seeing some pretty dynamic loads here. And race boats, it obviously is going to be a big deal, getting the weight out of the boats, getting the weight out of systems.
That's right, and we start going down the route of the cable of structured luff design and the weight savings we can make in the mast and rigging and boat weights, and it all impacts when we bring in foiling boats, the use of foils, just to make everything just so much more efficient. And then everything gets lighter, it all just works a whole lot better for us.
Yeah, and it's always easy to understand the application for new builds, and we just touched on the Marisha one, which was a pretty massive refit, but we've had a lot of success in being able to retrofit existing boats, hardwares, furlers, etc. Matt, you were fortunate enough to do the trip around the Horn with the Hataris. We had the JT up and deployed for a great portion of the trip. Tell us about the loading differences between the old and new setup, and again, I mean, we've touched on it again, but it's just nice to, hear a real case scenario.
Yeah, well, that boat's got a lot of load sails set up all over the place. It was really you could see it in the numbers straight away. Reggie's in the back there somewhere. I think is your previous jib top, you pre-tension the cable to 12 tons before you deploy? 16, and then it'd be way up over 20 when you're sailing. I think most of the time we're using it going across the Southern Ocean, we'd have it at 6 tons, and it'd be about 12 when you're sailing. I mean, it's a big drop in numbers. I mean, you just think about if you're engineering from scratch, what you could do, the weight you could take out of the bowsprit, your masthead locks, your furling gear, it all comes down. And it's a better sail. It's got bigger range. We had that up for literally 75% of the time going across the Southern Ocean. It's the go-to sail.
Yeah, and I guess, many super yachts traditionally have, had a furling pad eye in the stem and a 2-to-1 halyard, which, let's be honest, was pretty substandard when we were trying to hang cabled sails off it. I get, we're almost at the point now where that would be, we're close to a 1-to-1 halyard and a swiveling pad eye in the tack.
I mean, I've done a 1-to-1 halyard on a 80-footer. It's not quite a super yacht, but it did work. It was probably not perfect, but it showed that you don't need that huge amount of pre-tension. And yeah, if you can drop from a 20-ton lock to a 15-ton lock, it's great. But the 2-to-1 works really well. There's no problem with that. Mr. Which is that on that slide?
No,
all those boats are 2-to-1.
Oh yeah, all those boats. Leopard's on a lock, but.
Previously, in an ideal world, you'd want to be generating 15 ton of stay load just to deploy the things, which you're not going to get with a 2-to-1 halyard, plus all the compression that puts in the rig. But now those loads come way, way down. So again, a 2-to-1 is now a viable option. So people don't have to be scared about, I'm not going to get a code sail, or I'm not going to get this because I've got to put a big lock in it and beef all the gear up. No, it's not necessary now.
And Stu, that's probably, in raceboat world, take the Super Series 52, which then turns into an IRC boat. There was obviously no consideration, for code zeros. No consideration in the mast design for a Genoa staysail. Obviously, then you go into the new builds, the new Bellamente. Had no, was just an upwind, downwind mast spec as is Cannonball and Vespa and stuff. So, what to next? I mean, obviously the Comanches of the world are one thing, but, retrofitting existing boats, where do you see the big gain?
It just gives the owners and the teams a lot more options in what they can do with a boat. You mentioned the TP52s that come from Super Series that just go up and down. But, instead of having to do expensive retrofits on rigs and bowsprits, you can basically just take the existing gear and start using cableless sails on them. And, that's a pretty nice way to go for an owner that's taking up handicap racing with a Grand Prix boat. And then you know, the new builds, we don't have to worry about over-engineering masts, bowsprits, etc. We can basically just sail around with these cable-less sails now at all sorts of different angles without having to over-engineer stuff.
Nice. Yeah, so cable-less jib top and then cable-less Jannar staysail, and yeah. So, apart from the cable on the bottom of the jib top, obviously. So, Richard, you know, we're seeing it in zeros, we're seeing it in jibs, we're seeing it in staysails. You know, we've seen it starting to have an impact in rig design and, you know, obviously boat design and boat weight and keel weight, and then, you know, obviously there's going to be considerable trickle down from this. You know, what's on the horizon? You know, there's obviously one sail left on the boat. You know, is that real?
I think as it's evolved, you know, when we first started again and fell upon with the Code Zero, and it's progressed into all of the front sails on the boat now, in one form or another. Every sail that we build, cruising boat or racing boat, has some form of what we've learned and evolved this technology with. And there's no question, I think, you know, the next obvious step where this will have a big impact, or it's already in some of the projects that we're working on, is mainsails. And I think, you know, it'll work slightly differently. I think it'll have slightly different effects, but I think it's the same load reduction gains are going to be seen in the mainsail, potentially higher load reductions in certain aspects. And as a trimming device, it can be very powerful with a change to the structure and the way that we currently use it. So it's going to affect every sail that we make from here on.
That's what you call a very politically correct answer from an America's Cup designer. So you know, we won't delve too much into that. But you know, obviously, you know, there's a lot of exciting things going on. You know, on all Grand Prix boats, on all boats. I think one of the big points we sort of wanted to get through today is that it is relevant, you know, for every boat. We are integrating the technology into every front sail at the moment, which you know, we're designing, to be honest, and building. And although not all of them, we're going as far enough. You know, there's sort of a crossover where we can get away with it with our conventional sail building technique, and then we have to switch into the lens, the Luff lens group, when you get past a certain percentage. So no, it's, you know, it's exciting times. We're very passionate about it. We're very, you know, proud of where we've got to with it. Many of you in the room here have obviously been involved through the projects and through the profession. And, you know, we're really excited about the future, where it's going to take us all, to be honest. I mean, in all seriousness, it could be the first thing, maybe ever, that could bring the price of a yacht down. And that's, you know, that's real. You know, if you are talking about taking structure out of boats, weight out of boats, means, you know, material means everything. So
it's not going to bring the price of sales down.
No, the price of sales go up a little bit, but not. But no, listen, I'm conscious we're taking up serious socialising time, but does anyone have any questions? Please, you know, we've got the guys here. Has anyone got anything they'd like to ask while we've got them?
I've got a question, quick one, very interesting. There's loads of potential there, but a couple of areas that jump off the paper at you, apart from the mainsail one, is immediately freestanding rigs.
Yeah.
Freestanding rigs, headsails on freestanding rigs, and big cats, you know, which have always suffered. Have you already started fitting to those sort of vessels?
Freestanding rigs, I'm not sure, but certainly multi-hulls. We've done quite a lot on multi-hulls already, the Mod 70 and others, where we've seen massive gains in performance with it. So, I mean, there'd be any situation where you are struggling for headstay tension. So a freestanding rig would be a good example of that. You're going to get very big gains in performance, and you're like noticeable straight off the bat. Wow, this is amazing. Type.
Obviously, the more headstay sag you're currently dealing with, the more the gain would be. So in the 52s and 72s, obviously we're playing in a small pond, and as you say, on a freestanding or a multi-hole rig, you know, the gains are massive, as they were in Code Zero world. So it'd be very similar, you know.
It's interesting that on the case that nothing's new, Jeff Mail tried.
Oh, hey, see, and that's why you're not allowed to sit in the front, mate.
He tried to do this with Flying Dutchmans with bits of wire.
Yeah.
And couldn't do it because it got all lumpy.
Yeah, absolutely.
Yeah.
And, you know, Robbie was quoting, you know, the 83 America's Cup, where they were trying, you know, they found the more hollow they were putting into the luffs of jibs, the more headstay sag they were getting. And, you know, as they actually built structure back into the luffs of the sails, they were adding more luff curve back into them, and the headstay was, you know, was coming back up onto centre line. So, no, unfortunately, there is nothing new. It always cracks me up when if you go back a couple of shots to the triple heading, you know, when we get all excited about that, and then you see a picture of it.
Pictures like that.
Well, you see a picture.
They call it the cutty sack.
Yeah, and we call it the cutty sark on the boat. So, yeah, there's nothing new. You're right.
Yeah, I mean, it's really it's the
thanks for that, Chris. On that note, we'll.
You've made it flow.
Yeah.
What's
I'm joking.
is that we have the materials now and design tools to be able to do it and make it work. And the primary limitations now are going to be the evolution of what we attach the sails to. You know, the furlers, they're going to be the more of the next step to the change, if you like.
Yeah, and I mean, for me, the most exciting part, I mean, you just take the 72. I mean, our ratio of keel to bulb is 2.5 or something, right? So if we can pull, you know, 50 kilos out of the mast because we've reduced the compression significantly, you know, that means we're sailing, take the 50 out of the rig, take 100 out of the bulb, plus a bit, you know, we're suddenly sailing with a 150 kilo lighter boat for the same riding moment, you know, with less pitching issues. And so if you could end up with a package which has more control for lighter weight for a given riding moment, I think we all know what the result would be on the racetrack. So, you know, that's probably where my excitement comes from it. And, you know, the more time we're spending on it, you know, one of our early issues is we were lacking the range and the sail depth. The trimmers were saying, you know, for example, the Comanche style, where the luff sling is attached to the tack and head plate, of course, you can't change the depth of the sail, but as time goes on, we're learning that the ratio between the stay and be it the forestay or the luff sling and the jib, is actually giving us more depth range than what you're getting in a conventional jib runner forestay setup. And so that's just going to mean that boats have to carry less jibs, which isn't very smart on our part. But, you know, it means we'll be going through the range better and better. Anyone else? Lovely, guys. Well, listen, thank you very much for coming. Well done for finding it all, because I was pretty lost getting here. So obviously the smart ones made it here, and the smart ones will get this. So thanks very much for coming. Have a great show. Please stay around, have a beer, a glass of wine, and yeah, we look forward to talking to you all about the world of cableless. So thank you.